I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Hi. Today we're going to talk about power, and I know a whole lot about power. I done watched that Power Rangers movie 417 times. Power Rangers, they got power. They got the red one. They got what? Oh, he says the powers is about exponents today. I don't know much about that. I think I better go take a seat. This is operations with powers. And by powers, I mean exponents. Here we have a 5. That's the base. The 0 is the exponent. It raises it to a power. This is A2.APR.A.1, and it's A2.APR.A3. And if we were in Algebra 1, it would be the same letters with an A1 instead of an A2. It says I can perform operations and expressions involving powers. My video goes here. Today I've given you 4. One of those will show a little bit in class. If you don't get anything from my video, please get the other videos and learn about powers. The first rule I want to talk about is the 0 power rule. Anything that is 0 power is 1. What's 0 to the first power? That would be 0. What's 0 to the second power? Let's see. 0 times 0. Yep, that one's 0 too. But anything that is 0 power, by definition, is 1. On the Algebra 1 EOC, you saw a huge parenthesis with a whole lot of computations in it. And then they raised that parenthesis to a 0 power. And I guess they wanted you to waste 15 minutes doing all that math inside the parenthesis. But when the parenthesis goes to 0 power, the whole parenthesis is equal to 1. Rule 1, the 0 power rule, is any variable or number to the 0 power is always equal to 1. This should make sense because what you learn about the place value in elementary school, you learned that we had units, then you had 10 to the 1 column, then you had 10 to the 2 column, you call those hundreds. And probably even in elementary school, you got to 10 to the 3rd column, which is thousands. But that units column, we also call that the ones column. So anything that is 0 power is 1. Next, we have the negative exponent rule. All negative exponents go either up or down across the fraction bar. If it's on the top, it goes to the bottom. If it's on the bottom, it moves to the top. The exponent loses its negativity when it crosses that bar. So 5 to the negative 1 is 1 over 5. X to the minus 1 is 1 over x. And 1 over x to the minus 1, it's on the bottom. We're going to raise it to the top with no fraction. So that becomes x to the 1. 5 to the minus 3 is the same thing as 1 over 5 to the 3. And 5 to the 3, check my math on this, but I think it's 5 times 5 is 25 times 5 is 125. X to the minus 7 goes underneath the fraction bar and it becomes 1 over x to the minus 7. Yeah, you're right. I just told you, when it leaves the fraction bar, it gets rid of the minus sign. So this becomes a plus 7. X to the minus 7 is equal to 1 over x to the 7. Next, we have the product of power rules. When you multiply like bases, add the exponents. When you multiply like bases, add the exponents. 5 to the 6 times 5 to the 7th. They got to be like bases. You can't do it with x and 5. You can't do it with 5 and 6. You can't do it with x and y. 6 plus 7 is 13. And I don't know what 5 to the 13th is. You want to keep multiplying by 5. You go ahead. It's going to go off most calculators, but you try it. It might be on your calculator. You'll never know. My other example, x to the 7 times x to the 3 is x to the 10. The product of power rules is when you multiply like bases, add the exponents. Next, I have the quotient of power rule. This is the product of power rule. What do you think the quotient of power rule is? If you multiply like bases, you add the exponents. What do you think happens when you divide like bases? Yep, that's right. You're going to end up subtracting the exponents. The quotient of power rules. When you divide like bases, subtract the exponents. 5 to the 13th divided by 5 to the 7th. Doesn't matter if 7 doesn't go into 13, because all we're doing with the exponent is subtracting. 13 minus 7 is 6. X to the 7th divided by x to the 3rd is x to the 4th. X to the 7th divided by x to the 9th. 7 minus 9 is minus 2. And then we go back up to the negative power rule up here. So x to the minus 2 is the same thing as 1 over x squared. So we're going to change that because this one involves two rules. It involves the quotient power rule and the negative exponent rule. I mean, you think on your next little quiz, I can have several that involve more than one of these rules. Yep, you're right. I can. Here's the power of a power rule. If you raise an exponent to an exponent, that is, we have 4 squared, and we're going to multiply that times itself 3 times. The exponent actually means 4 squared times 4 squared times 4 squared. If you add all that up, you got 6 of them. So the power of a power rule is when you take a power to a power, that is when you raise an exponent to an exponent, you multiply the exponents. 4 squared cubed is 4 to the 6th, which I think you better, I'll get a calculator because I don't know if I can do this in my head, but I think I came out with 4096, 4096. 15 to the x to the 15th power squared is really x to the 15th times x to the 15th. When you add those exponents, you still get 30. So here we're going to multiply and still get 30. Next, I have the power of a product rule and the power of the quotient rule. Basically, they're the same rule. And all you have to know to do that rule is you have to know about parentheses. When I cube the parenthesis, I cube everything in it. When I raise the second parenthesis here to the 4th power, I have 2 terms in there. I have a 7 and an x squared. The division is inside the parentheses. So when I 4th power it, I take the 4th power of everything in the parentheses. It still becomes, it's still a division problem. So 7 to the 4th power over x to the 8th power. How do I get that one? When you take exponent to an exponent, you multiply the 2 times the 4. You don't add them. And then down here, I have a chart out of your book that defines all the exponent powers. And we're going to work with these a couple days. And then we'll see if we can find a quiz. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.